Power and efficiency. What is the definition of power? Power is basically work done divided by the time doing it. The unit of work is in joules, and the unit of time is in seconds. So power will equals to joules per second, or we can call it as watt. As for examples, the water heater here uses 1200 watt per times uses. As we can see, it is simply described as watt. Horsepower is in British system. So 1 horsepower equals to 746 watt, which we can write out the equation as Before moving on, let's see a little more about work. Work is up to the system we are looking at. There is many kind of work. As examples, a 60 kilogram jogger runs up a long flight of stairs in 4 seconds. The vertical height of the stair is 4.5 meters. Estimate the jogger's power output in watt and horsepower. Firstly, we write out the equation. Average power equals to work over time, which work here equals to mgh. Because the guy is walking up the stairs. Now we plug in all the variables. And this all will equals to 660 watt. To make it in horsepower, we plug it in the equation. So 660 over 746 will equals to 0.88 horsepower. Let's see for another form of work. Calculate the power required of a 1,400 kilograms car under the following circumstances. The car climbs 10 degrees hill at a steady speed of 22 meters per second, and the friction is 700 Newton. So we firstly write out the equation. In this case, the work is equals to force time distance. As we can see, distance over times here, it's equals to velocity. So we make it to force time velocity. The force here is 700, which is the friction, plus mg, the weight, sine theta. Which of this will equals to 3,100 Newton. We plug into the powers equation. Power equals to 3,100 times with 22. This will equals to 68 kilowatt. Efficiency is defined as a ratio of the useful power output of engine to the power of input. The efficiency is always lesser than 1 because no energy can create an energy, and no engine can even transform energy from one form to another form without some energy going to friction, thermal energy, and other non-useful form of energy. Nearly 85% of the input is wasted. To clarify, let's look at these examples. So the input of energy is 100, and the output energy will be 75. Then we will need to write out the equation. As we can see, efficiency is equals to output power over input. The output here is 75 over 100. So it is equals to 0.75. It should be make 2%, so we times it by 100. And this will equals to 75% efficiency. This video covers all the topic of power and efficiency. Thank you so much for watching.